What does it take to build an AI that truly understands a resume? I'm Alvin Moyo. In this video, I'll walk you through the journey of how I built and evolved a resume ranking pipeline, starting with traditional machine learning and pushing towards something smarter. Along the way, I will show you how real-world data and advanced AI reshaped how we think about candidate fit. Let's dive right in. The challenge is global. Too many resumes, not enough time. I started with 104 candidate profiles. While the first version explored data as is, the second pipeline required more structure. After rigorous cleaning, deduplication, and standardization, I refined the dataset down to 53 high-quality profiles. This became the mission control for the rest of the project. As you can see, the data in these columns: ID, job title, location, connection score from 0 to plus 500, fit score, which is to be predicted whether a candidate fits or does not. So there are the job titles, various job titles, and the locations. As you can see, it's all over. It's more of a global list, and the ID is pretty straightforward because it's personal data. So we just used simple identifiers like 1, 2, 3 until 104. So this is the data with 104 rows and 5 columns. The first pipeline used NLP tools. TF-IDF scored candidates on keyword matches, while powerful embedding models like S-BERT, GLOVE, word-to-vec, and fast text captured their deeper semantic meaning. We then fed all this into a random forest classifier to predict a final fit score. The heat map here just shows rank alignment across the embedding models. Here is how it worked under the hood. Each profile was transformed into a feature vector using TF-IDF. And we used k-means clustering to see how candidates grouped together based on keywords. This gave us insights into how candidates grouped by skill sets and how our score-based model aligned with those clusters. To go a step further, we trained a random forest classifier on these feature vectors, including TF, IDF, and S-BERT representations, to generate a concrete fit score. This moved beyond simple similarity to a predictive model, allowing us to rank the entire list from most to least likely to be a good fit. But I wasn't satisfied. A score is just a number. What if AI could explain its choices? What if it could reason like a recruiter? That led to pipeline version 2. In version 2, I brought in the big guns. OpenAI's GPT-4o, Alibaba's Qwen, and Facebook or Meta's Llama 2. Each one is asked to directly rank candidates, not just score them. The goal is to simulate expert judgment, not just numerical predictions. We then used a tournament-style strategy. The 53 profiles were split into smaller groups. Each large language model ranked candidates within its group, allowing for focused comparison. These partial rankings were then reconciled using a custom consensus-based logic that merges the AI's opinion into one final unified list. So here we just scored all of the candidates from number 1 to number 54. And GPT-4 gave a rank, Qwen gave a rank, and Llama also gave a rank. And each of the models gave a justification of why a particular candidate got the particular rank according to the fit that title has to the desired role. This is where things change. GPT-4o doesn't just assign a number. It synthesizes everything we built so far. Semantic clusters from S-BERT and UMAP, fine-grained candidate scores from multiple LLMs, the final thresholded fit scores, and even filtering rules. From all this, it delivers a refined shortlist. Crucially, it justifies every selection. This is no longer just a black box. It's a recruiter's assistant that thinks in context and speaks with clarity. And this is just code to show a prompt we gave to GPT-4. And this is the final shortlist that it managed to give with the candidate ID, the short title, the cluster to which they belong to, and the justification. For example, excellent composite score and human input enhancing cluster diversity, high fit and composite scores, strong consensus across model rankings. So this is the output from GPT-4. So what did we build? 2 pipelines with one goal. The first offers a score-based approach rooted in machine learning. The second brings reasoning and justification into the mix using large language models. Together, they showcase the evolution of AI in recruitment, from scoring to reasoning. The full project is live on GitHub. Check out the notebooks and the visuals for yourself. I will leave a link for the GitHub repo and my LinkedIn in the comment section. Thank you for coming along to this AI-powered journey. And if you enjoyed it, don't forget to like, to subscribe, and to share. Until the next one, happy coding.